Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me on yet another video where we're going to be learning and exploring the Rust programming language. Now, before we get into today's topic, please like this video, subscribe to the channel, and comment down below. I am an independent content creator, and your support will help me to produce more videos and grow the community surrounding the various technologies that I talk about. Now, with that out of the way, the topic for this particular video, as you probably inferred from the video title itself, is going to be learning about things like conditional expressions, as well as the control flow statements that are available inside of the Rust language. Now, if you're following along with the playlist, which I'll have linked down below in the description, as well as the pinned comment, then you'll probably know that we talked about things like modules, right? And modules allow us to kind of categorize our code and create child modules that are nested inside of parent modules and help to split our code across multiple files. So if you're interested in learning about modules, make sure that you go back and watch that video. But if you are more interested in written form content around control flow statements, make sure that you check out these resources here. First of all, we have the Rust programming language book that is kind of the main documentation behind Rust. It kind of goes through the introduction here. But then under section 3 of the Rust programming language book, there are control flow statements. It talks about if statements, while statements, loop statements, and things of that nature. There's also another resource called the Rust reference, which is kind of the authoritative reference for the exact syntax of different types of statements in Rust. And if you go down to section 8 under statements and expressions here, this is where you'll find sections like 8.2.13 that cover loop expressions, which also includes while expressions. Then you have 8.2.15 that covers if and if else statements. And then we also have 8.2.16 here that covers how match expressions work, which is similar to a switch statement in some other languages. Also, there is Rust by example here, and in the Rust by example book, if you go over to the section 8, there is flow of control. We've got if-else statements, loop statements, while statements, for statements, and things of that nature. So feel free to check that out. But if you need even further help on Rust, feel free to get over to the discussion forums, which is a discourse-based forum. It's really nice software that allows you to host your own discussion forum. But that's what the Rust programming language uses in order to communicate with the rest of the community. So with those resources out of the way, let's actually jump into some actual code so that we can understand how control flow statements and the conditional expressions that we typically use to test certain conditions as either being true or false work inside of this language. Now, for starters here, I'm going to comment out the code that we were using to test out function calls to separate modules in our code project here. And then down towards the end here, I'll go ahead and add in the code for our examples here. So what I'm going to do is actually define some separate functions for each of our examples here. And let's start out with one of the most basic things, which is the if expression. So what we'll do is create a function here and say test if. And then inside of this function, we're just going to write some simple if statements. Now, let's come up with some common scenarios that we might come across to determine how our if conditionals are going to work. So let's say that a driver's age limit is 16, as it often is in the United States. So let's say that our age in order to be able to drive is going to be 16. So we'll say age to drive is equal to the value of 16. And I'll just make that an unsigned 8-bit integer, since that's kind of the data type that makes the most sense to contain an age, because unsigned integers can't be negative and ages can't be negative either. Now let's prompt for a particular age. So one of the useful things that you're going to learn here is how to actually prompt for input from your Rust program. Let's start by providing a prompt using the printline macro that we've been using up until this point. So we'll say enter the person's age, okay? And then after that, what we need to do is to actually accept the person's age as input so that we can determine whether they are old enough to drive or not. So what we're going to do is go out to the standard library. We're going to go into the IO module, and then we're going to find the standard input here. So the standard input function, and then we are going to call the readline function here, and that's going to allow us to accept input from our program. Now, the readline function here takes a buffer as an input argument here, and this allows us to pass in a pointer to a mutable string that is going to accept the input from the terminal. So the first thing that we need to do is initialize this buffer as a mutable string, or a pointer to a mutable string value. So what we'll do is say let my input equal, and then we're going to say pointer to a mutable string, and then we'll use string : from and just specify an empty string value. So what this is going to do is initialize our string buffer to just an empty string value, but it's going to be a pointer to a mutable string. So now we need to pass that buffer into our readline function here, and we'll just do my input. Go ahead and save that. We'll put a semicolon at the end here as well. And you're going to notice that we have this message here saying that there's an unused result. So what I'm going to do is just kind of discard the result that comes back from the readline function because we're passing in a pointer to a mutable string. So I'm just going to do dot unwrap here, and that'll get rid of the warning that I'm not using the result object that's coming back from the readline function. All right, now we get a couple other warnings here because we're not calling the test if function and we're not using age to drive yet, but we'll resolve those in just a moment. So let's go ahead and take the input that we're getting here and test to see if the age is over the age to drive or not. So what we'll say is if my input is greater than the age to drive, we'll actually do greater than or equal to, and say age to drive, then inside of these curly braces here, I can put some logic to execute if the person is old enough. So we'll say print line issuing driver's license because they are old enough. And then we'll put a semicolon right there at the end. But now you're going to see that we have a little bit of a type mismatch here. And this is happening because the age to drive here is an unsigned 8-bit integer. So the unsigned 8-bit integer cannot be directly compared to the pointer to a mutable string. So what we need to do is actually turn this mutable string into an unsigned 8-bit integer so that we can determine if it's greater than or less than the age to drive here. So once the buffer has been filled by this readline call right here, we need to take the my input buffer and cast it as a unsigned 8-bit integer. So to do that, what we're going to do is say my input, and then we're going to use this method on that called parse. And the parse method here is going to allow us to convert this string into the unsigned 8-bit integer type. So what we'll do is call parse and specify that we want a U8, and then we'll go ahead and just unwrap that value and assign the value to a new variable. So let's go over here on the left and say let age equal the result of this expression right here, and that'll take our string and turn it into this unsigned 8-bit integer, which we can then compare against the age to drive variable. So now down here, we just need to replace my input with age, and now the comparison here is valid. So let's go ahead and call this function from our main function. So we'll do test if right here, and then we can go ahead and do a cargo run to see if our application works. So as you can see, we are being prompted for input here. It says enter the person's age. So I'll just do 15 for starters right here. And as you can see, we are getting an error here. Now, on first glance, this error might not be totally obvious because if you inspect the error message, you can see that it says there is an invalid digit. But you're probably looking at your input here, which is just a 1 and a 5, and you're probably thinking, well, those are valid digits, so why can't I parse that as an unsigned 8-bit integer? It's not a negative value, right? So why is this not parsing properly? Well, what you may not see here is that when we call the readline function here, this is actually including not just the values that you typed here, but it also includes the new line character in Rust. So even though it's invisible to the eye, we actually have 1.5 followed by a new line character, and that new line character can't be parsed to an unsigned 8-bit integer. In order to resolve this, we actually need to basically remove that new line character. And one of the ways that we can do it is to go to my input and simply call the replace function here. And then we can replace the /n character, which is the new line character. And we'll specify that we want to replace the new line character with an empty string. So we're going from a new line character to nothing here, and that will strip any of those new line characters from our string. So then we'll just be left with the 1.5 digits, and if we try to run our application again, you should see that it works just fine this time. Of course, the program exited without printing anything because 15 is less than 16, which is our age to drive. Let's go ahead and try to run the application again. So let's plug in 16, and because 16 is equal or greater than 16, that works just fine. Let's test again with a number like maybe 26. And once again, we can see that the driver's license can be issued because 26 is greater than 16. So that's how we can prompt for user input, perform a type conversion, and then use the if statement here to perform a comparison against a different value. Now we can also use else statements. So previously, when we specified 15 as an input, we didn't get any output printed here. It just returned back to our prompt. However, if we plug in an else statement here, we can kind of do a catch-all so that if the condition in our if statement doesn't match, the else statement will be executed. So let's do a print line here and say, wait a bit longer. You aren't old enough for a driver's license. All right, put a semicolon there at the end to make the compiler happy, and then we'll go ahead and run, and then we'll plug in a value like 15, and sure enough, it says wait a bit longer, you aren't old enough. Let's try with another value like 13, and once again, it prints out the wait a little bit longer. All right, so that's a really simple if statement, but we can also use else if statements. And so if we say else if, and then put in a block right before our else statement here, we can add some additional logic that determines what can happen if we plug in another expression. So let's say that you have to be older than 16, but not equal to 16. So we'll say that if the current age is equal to 16, and when we do a comparison, we use the double equals here, then we'll say print line, you are just on the verge of being old enough. Wait one more year. So now we have an extra expression in here that will catch if we plug in 16. It says you are just on the verge of being old enough. Wait one more year. Or if we wanted to catch a range, so if we say age is equal to 16, or so we could do a double pipe character there and say age is greater than 14, then we'll just go ahead and include those ages as well. So 15 and 16 should be valid values. Let's do another run and we'll plug in 14. And now 14 is caught by this else if statement as well. However, if we go down to 13, then it should say, wait a bit longer, you aren't old enough. So that's how we can use if, else if, and else statements to check our conditional logic and perform various actions based on the trueness or falseness of those statements. One other interesting thing that you can do with if statements is actually use them in variable assignment expressions. So let's say that we have a variable called let driver's license equal maybe false for starters. So we'll just make this a Boolean data type here. And then we want to set the trueness or falseness of this driver's license variable based on the age here, right? What you might normally do is just go to the next line right here and say if the age is greater than or equal to 16, then set driver's license equal to true, right? But we don't actually have to do that because in our let expression right here, we can simply say if age is greater than or equal to 16, then go ahead and return true. Otherwise, we can return false. And we don't need the semicolon right there after true. For really simple conditional statements, this is a lot more concise because we have everything on one line right here. But if you do have more complex expressions that you need to run, then you can use the long form of the if, else if, and else statements here. So now that we have a better understanding of if statements, let's go ahead and move on to some of the looping constructs available in Rust. And one of those is known as the while statement. So what I'm going to do for starters right here is to just close off this function, and we're going to comment this out, and then we're going to create a new function for testing while statements. So let's do fn test while, and then we'll go ahead and just call that from our main function here. And for starters, let's go ahead and implement a simple while loop. Also, I'm going to use the allow dead code here just to avoid that warning from popping up. And then under the test while function, let's go ahead and implement a simple while loop. So what we can do for starters here is to just implement a simple while block that says while true, and then we can say print line waiting. All right. Now this isn't very interesting here, but this is what's known as an infinite loop here. And so if we just say while true, then true is always true, right? And so as long as the conditional expression here is set to true, the while loop is just going to continue to loop. And if we were to run this code here, you'll just see that it infinitely prints out waiting. So what we typically want to do is to have some kind of condition where the while loop is going to exit, right? So using our previous example where the age to drive is 16, let's just say age to drive is equal to 16 as an unsigned 8-bit integer. And then let's just say let current age, so this is the person's current age that they are. Let's say that a person starts at 0, and we'll express that as an unsigned 8-bit integer as well. But now in our while statement here, we're going to change the conditional expression to say while current age is less than the age to drive, then we're going to print out waiting. So now we've implemented a condition that says if this condition is ever false, then we want to go ahead and exit the loop, right? So starting at 0, we should just print out that value. Of course, I totally forgot to increment current age. So inside of our while block here, we're just going to say current age plus equals 1. And that will increment the current age every single time that we loop. But of course, the variable is immutable by default. So we need to turn it into a mutable variable with the mute keyword or MUT. And now if we do a cargo run, this is going to be printed out up to 15 times until we reach the age to drive, which is 16, and then the while loop will exit and our entire program will exit because that's the last statement in our main function here, right? So that's a simple example of a while loop, but you can actually exit while loops early as well. So if I wanted to, I could go into this while loop and say, if the current age is equal to 6, then I want to use the break command here, and that will actually tell the while loop that I want to artificially exit out of it before the conditional logic that we have in the while expression here is met. So now if we run this again, you can see that waiting is only printed out 6 times here rather than the 15 times that we would expect for the first iteration, or actually I think it's 16 for the first iteration since we start from 0 and go all the way up to 15 and then 16. All right, so that is a while loop, but Rust also supports a loop keyword. So let's go ahead and implement yet another function here. So we'll say fn test loop, and the loop keyword, similar to doing a while true, is always going to loop unless you explicitly break out of it like we just saw with the while statement. So let's just do a loop block here, and we'll just say print line hello from Rust, and we'll insert a little crab emoji there as well. And so at this point, if we just do a cargo run, then we of course get nothing because we didn't call this function here. So let's call test loop from main. And so once again, we're in this infinite looping scenario where the loop construct never exits. Now, unlike the while statement, the loop doesn't allow you to specify a condition afterwards. So if we said x is less than 5 or something like that, you're going to see that it expected there to be a code block, not a conditional expression. So what we could do is just say something like, if x is greater than 5, then go ahead and call the break statement. And up here, we'll just declare a variable. Let's say x is equal to 1. And then we'll just do an x plus equals 1 inside of the body of the loop right here and turn x into a mutable variable. Once again, just do a cargo run here. And it looks like we have an issue with our expression here. Of course, I need a semicolon right after print line there. And now you can see that we are exiting after 6 iterations here. So we are looping a number of times, but as soon as x is larger than 5, then we exit out of the loop. All right, so that is the looping construct. And I think the last thing I wanted to talk about is the for loop in Rust as well. So the for loop allows us to iterate across a number of elements. So what we're going to do is just comment this out once again, create a new function and say test for. And inside of this function, which we'll also call from main here, we're just going to start out with something simple like an array of values. Now, we talked about arrays back in our data types video, so feel free to go back to that video if you are interested. But an array can have an array of values based on a particular data type. So it could be a string pointer, it could be integer values, it could be floating point values, or even custom structs if you wanted to. But for now, let's just create an array of values like ages, and we'll set this equal to an array like maybe 18, 26, 35, and 41. All right, so now we've initialized this array. They're all 32-bit integer values. And what we want to do now is to iterate across these ages, right? Let's actually plug another one in there, 14, because 14 will be less than the age to drive. So we'll say let age to drive equal 16. But we also want to make sure that that's being expressed as a 32-bit integer, since that is what our array is based on here as well. So now what we want to do is to iterate over each of the ages inside of this array to determine if that individual value in the array is old enough to drive or not. So we're going to embed an if expression inside of our for loop as we iterate across each of these ages. So what we want to do is say for value in ages. And so this syntax right here is how we take an array of elements and then iterate across it. And as you can see, Rust is able to infer the data type based on the data type of the ages array. The ages array is an i32 with 5 elements. And so therefore, Rust knows that value here should be an i32 because that matches up with the data type of each individual element inside of the array. So what we'll do inside of the for loop here is go ahead and just use that value variable that's being iterated with, and we'll say the current age is, and then we'll put a 0 placeholder, and we'll pass in the value. So now if we run this, you can see that we iterate across each element and we run the print line statement. But now we want to do a comparison on is able to drive or not. So what we'll do is say if the value, so that's the current value that we're iterating on, is greater than or equal to the age to drive, then we'll say print line, you are old enough to drive. And then we'll say else, if it's not greater than or equal to the age to drive, we'll say print line, you need to wait a little bit more. And I'll put semicolons there just for good measure. And let's do a cargo run. And as you can see, the first age in our array, which is 14, is less than the age to drive. So they need to wait a little bit more time. And then the remainder, 18, 26, 35, and 41, are all greater than the age to drive. So all of those people can drive. And so this condition right here is being matched. So those are just some of the fundamental control flow statements that we have in the Rust language. And you can use those for a variety of different purposes. This is just kind of a contrived example that I used here with the age to drive, but you could use a whole bunch of other practical real world use cases with these types of control flow statements. So I hope you guys enjoyed this video. Again, please like this video, subscribe to the channel if you'd like to see more videos from me, and make sure to leave a comment down below and let me know your thoughts on this particular video. Thanks, and we'll see you in the next video. Take care.